be working on in class. Okay, these are the homework questions. And I just realized that I decided to take up one of the questions that's not assigned. So you are assigned D to F. Okay, so those are these. And then all of question 8, question 10, and 11. And I remember from teaching this course in other years that students really struggled with these area questions, right? So make sure you review them and do them over again if you need to. So I'm going to start with question 7E. I need a lot of space here. Okay, let's write it out. We've got 2x squared minus 5x. Now, I hope that you have tried this question before watching this video. That's the idea. If you haven't, pause the video or close it, try these questions, and then watch, right? And then if you are watching it and you're like, oh, now I know what to do, then stop the video and try this on your own, right? It is best for your brain when you really struggle and try on your own. Ooh, I feel like this one might be a perfect square trinomial. Maybe. Let's see. Okay, so lots going on here. Let's color code this. Okay, so I'm going to start. So because there's so much going on, I'm going to do all my work separately and then bring it back into the original simplification or expression. So I've got 2x squared minus 5x minus 3. Looking for two numbers that add up to negative 5, multiply to give me negative 6. So add up to equal negative 5, multiply to equal negative 6. Is it going to be negative 6 plus 1? Yes, negative 6 plus positive 1. Okay, so let's decompose. Don't forget your equal signs. Okay, we're going to factor by grouping. So this first group has a common factor of 2x. And so I have x minus 3. And the second group does not have a common factor, so we leave it as 1, x minus 3. And we need to leave that 1 there, or we need to factor it out so that I can write 2x plus 1, as opposed to not write anything for this part. Okay, let's factor this expression. I've got 2x squared minus 11x plus 15. So looking for two numbers that add up to negative 11 and multiply to give me, this is supposed to say plus 15, to give me 30, positive 30. Okay, it's going to be 6 and 5, and they're both going to be negative. Negative 6, negative 5. Okay, so let's decompose the middle term. Negative 6x, negative 5x plus 15. And so if you're not sure if you decomposed correctly, check. If I add up these two values, negative 6x and negative 5x, do they equate to negative 11x? They should, right? Because we've just broken them down. Okay, again, we're factoring the groups. So the common factor here is 2x, x minus 3. The common factor here is going to be, because I want my second term to be negative, I'm going to make it negative 5. And that gives me x minus 3. If you made it positive, this would be positive, this would be negative, right? So you must consider whether it's a good idea to factor out the negative or not. Okay, so we've got that piece. Okay, let's factor this third term. Okay, so we've got 4 x squared minus 8x minus 5. Okay, two numbers that add up to give me negative 8 and multiply to give me negative 20. Okay, let's see. I'm thinking here real time. It's going to be 10 and 2. So it has to be negative 10 and positive 2. Okay, so I'm decomposing negative 10x plus 2x minus 5. Drop the 4x squared, add an equal sign. First group, common factor, 2x, leaving us with 2x minus 5. Ooh, look at the second group. 2x minus 5 already exists, but I need to add something here, so it will be simply plus 1. 2x minus 5 times 2x plus 1. Now, remember that if you're not sure if you factored correctly, you can always expand these two terms, these two binomials, to see if you end up with the answer, right? Just reverse the process. Okay, and now this last one, which I have recognized as a perfect square trinomial. So we have 4x squared plus 4x plus 1. And so what I believe this to be is, hey, this first term has a perfect square. It is 2x. 2x times 2x is 4x squared. 1 has a perfect square root. It is positive 1. So I am suggesting that this be the answer. And the way that I check is I check if the middle term is the result of the product, so multiplication, the product of these terms doubled. 2x times 1, right? So I'm saying 2x times positive 1 times 2, right? To double it. And yes, that gives me 4x positive. So as such, it's a perfect square trinomial. And if you didn't catch that and you use decomposition, you will end up with the same factors. Okay. So now we write this expression in factored form. And I'll just use the colors so that you can see where each factors came from. Okay, the green is going to be x minus 3, 2x minus 5. And then this term gets us to 2x minus 5, 2x plus 1. Okay, so really driving home the importance of factoring, right? And quick factoring. Okay, so I can cross cancel, or I can cancel the x minus 3s. I can cancel the 2x minus 5s. I can cancel, so remember 2x plus 1, there's two of them. So one of them just removes the squared, and then I have another 2x plus 1 that removes everything. So this is crazy, if I did this correctly, that would mean that the answer to this simplification, or the simplified version, is just 1. Such that, now let's look at our restrictions. X cannot be positive 3. And then I might need to do a bit of work. You might be able to do this in your head. If I have 2x minus 5 equaling or not being able to equal 0, that means 2x cannot be equal positive 5. Divide both sides by 2. And so that means that x cannot equal to 5 over 2. And the last restriction is going to be that 2x plus 1 cannot equal to 0. So that means 2x plus 1 cannot be equal to negative 1 divided by 2. means that x also cannot equal to negative 1 over 2. Okay, that is like, just check the length of this solution, right? That's a big question. Lots of factoring. All right, next I want to look at the second question, question 8c, in which we have two variables. Okay, and I'll show you how to deal with these two variables. So let's see, maybe if I take this, copy, and paste it here. Great. So which one did I say? I'm going to do question 8c. And if you feel ready, please start without me, right? And then maybe press play if you need to check. Okay, so I see again we are going to be writing the reciprocal of the second rational expression. And I'm going to color code from the start. So I've got a squared plus 15ab plus 56b squared over a squared minus 3ab minus 54b squared times. Now I am flipping this rational expression. So I have a squared plus 6ab minus 16b squared, right? And then in the numerator is the old denominator. Now I know that the two variables make it look scary, and actually all that you need to do is just add another variable into your binomials. So watch, I see there's an a squared and a b squared. That means each binomial is going to have a and a b, and that just takes care of it, right? Because a times b is ab. So I'm looking for two numbers that add up to 15 and multiply to 56. That is going to be positive 7 and positive 8. If your multiplication tables are not that strong, then I would encourage you to review your multiplication tables daily until you're able to come up with that fairly quickly. That will be really helpful. Okay. Otherwise, you could use a calculator. It just will take a bit more time to access that. So I know that I place an a and a b in each bracket, and because there isn't a coefficient in front of a squared, I don't need to decompose. So what adds up to negative 3 and multiplies to 54? So 54 is also 9 times 6. Perfect. So it's going to be 9 and 6. And because the sum is negative, the bigger number will be negative. Great. Let's factor out the purple expression. Okay, always looking out for a perfect square, but I do not see them in this question. So what adds up to 4 and multiplies to negative 12? That's going to be 6 and 2. So it's going to be positive 6, negative 2. Okay, and then the orange. Again, put the b's in the back of the binomial and an a in the front. Looking for two numbers that add up to 6 and multiply to 16. That's going to be 8 and 2. And because the sum added up is positive, that means the bigger number has to be positive, the smaller one is negative. Okay, that was a lot of work. That's the biggest part, right? Now you get the fun of cross canceling. So I see that I can cross cancel a minus 2b. I can cross cancel a plus 6b. I can cross cancel a plus 8b. And so what I'm left with is a plus 7b over a minus 9b. I hope you can, I'll rewrite that. A minus 9b. Okay, restrictions are a bit ugly, so let's do these quickly. And let's remember that we did take the reciprocal. So I need to keep in mind this binomial, which already is represented in the denominator, and this binomial, which is also represented in the denominator. So I'll take the first one. A minus 9b cannot be equal to 0. We usually write everything in terms of the first variable, which is a. So that means that a cannot be equal to 9b. You just move the 9b to the other side. Done. A cannot be equal to 9b. It's kind of a formula, okay? In this case, there are many values, and so for this, we just find formulas. I've got a plus 6b cannot be equal to 0. That means that a cannot be equal to negative 6b. There's another one. Okay, following the same pattern, I can say for this expression, because this is positive, that a cannot be equal to negative 8b. And lastly, because I have negative 2b, the opposite is true. A cannot be equal to positive 2b. I'll just draw a line here to separate them. Okay, so that's question 8c. And lastly, I said I would do question 11. So let's look at 10. So 10 basically saying is write the area of a rectangle in simplest form. Well, we're given the width here, and we're given the length here. And when we multiply, order doesn't matter. So if you say the other one is the length and this one is the width, that's fine. I know that area of a rectangle is length times width. So you're going to multiply and cross cancel these rational expressions. Now, that's for question 10. Question 11, we're looking at a trapezoid. So let's do some work and let's read the question carefully. The area of the trapezoid is. So in question 11, we are given that the area is 6y squared minus 5y minus 6. We are asked for the height, right? I'm kind of doing a problem using GRASS, that acronym. I'm also given the two lengths, okay, or the two bases. I think for a trapezoid, we're given this formula. So the area of a trapezoid is B1 plus B2, right? The two different bases divided by 2. So we take the average times the height. I'm going to do some algebra to isolate the height before I substitute any values. So I'll do it one step at a time. The opposite of divided by 2 is multiplying both sides by 2. That gets me 2a, these cancel, equals b1 plus b2 times height. And so if I want to move over the b1 plus b2, I see it's a factor and it's multiplying h. So what if I just divided both sides by b1 plus b2, right? Then I can cancel these. And here I have b1 plus b2. Okay, so make sure you see what I've done here. Okay, I think I'm gonna need more space. So I'm gonna take this and move it up. Where do I have more space? Here. Yeah. So this is solution to number 11. day 2. Okay, now let's see what other values we have. So we were given that a equals 6y squared. I have it up here. No, I don't. 6y squared minus 5y minus 6. Okay, I have that b1, which is any one of them, it doesn't matter, is y minus 4. That's the shorter one, fine. It doesn't matter because we're just adding them together. And the second base is 3y minus 2. Did I get it? Yeah. Okay, so let's use this simplified formula where we've isolated h. It's going to be 2 times the area over b1 plus b2. Okay, meaning 2 times 6y squared minus 5y minus 6. You could have factored that right away. I just wanted to show you all the steps here, but feel free to go a bit faster. So I have y minus 4 plus 3y minus 2. And when we're adding polynomials, I don't need to worry about, like if I were subtracting, I'd have to distribute the negative, but I'm not doing that here. Now, this is what you're going to want to do. You're going to want to expand the 2. Don't. We want to simplify. So we want to factor out as much as possible. And this 2 it's as if there was a common factor that was already factored out. Okay? I've got 2. Now I need to factor this on the side. So I'm looking for 2 numbers that add up to negative 5, right? I'm using decomposition and multiply to give me 6 times 6 is 36, negative 36. Right away, I see 36 is 4 times 9. It's a 9 times table. Okay, so it's going to be 9 and 4, and the 9 will be negative. So I'm decomposing 6y squared minus 9y plus 4y minus 6. First grouping, common factor of 3y. And so I have 2y minus 3. Second grouping, factor of positive 2, and I get 2y minus 3. 2y minus 3, 3y plus 2. Okay? And so I'll write in those factors. 2y minus 3 and 3y plus 2. And then for the denominator, we're just adding, right? We're not multiplying, we're adding. So I've got 3y and y, that's going to give me 4y. And negative 4 and negative 2, that's negative 6. Okay, now I don't want to rewrite. I guess I will. Okay, fine. I might. No, I don't want to rewrite all of this. But I will. 2y minus 3. Right, if I were you, I would just immediately factor out the 2 here. Right, we've got 2y minus 3. And so we can simplify the expression by cross-canceling 2 of the binomials. And then I have to think back. I'm like, what was I doing with this question? What's the whole point of this? Oh, wait, we were looking to solve for h. So h is this. And so the simplified version of the height is that the expression for height is 3y plus 2 over 2. Oh, the 2's cancel out. Beautiful. So even better. Cancel out the 2's. It is 3y plus 2. Okay, such that. Now, Did we take any reciprocals? Da, da, da. There was a 2, so that's fine. So now let's see. Okay, the only time that y was in the denominator was here. So I need to restrict this y. So 2y minus 3 cannot be equal to 0. Bring the 3 over, it's positive. You're going to divide everything by 2. So y cannot be equal to 3 over 2. And here is our height. Okay, could this kind of area question show up on a quiz? For sure. Right? Could any of these questions show up on a quiz? Absolutely. Okay, so do the homework questions. Work with your partner. Go to the whiteboards if you want. That's it.